Hey guys, let's talk about set builder notation. So we've talked about sets for quite a few years now. Again, remember when we talked about set, we put it in these little brackets like this, and we might have said that we want all the even numbers up to 10. And we would write it like that. Or we would say maybe we want all the vowels, so A, E, I, O, and U. It's just coincidental that they both have 5 members in it. We could have one that has infinitely many. Let's say we talked about the set of integers, and we would usually write it like this. So forth. It could be, they don't have to be letters or numbers. They could be, baseball cards or, I don't know anything about baseball, so I can't pick anything like that. But the list of Pokemon cards I have, so maybe you write Charizard or, something like that. They can be anything. It's just a collection. Things that we know are that you don't ever repeat the elements in it. So I wouldn't say 2, 4, 6, 8, 4, 10. I wouldn't write down something twice. And also order doesn't matter. So if I did it 2, 4, 6, 8, 10, that is the same thing as the set 10, 4, 6, 2, 8. Right? Order in a set doesn't matter. Okay. What we're going to talk about today, though, is set builder notation. So how we can write a set by just a description, right? So it's going to start out the same. So we're going to write something like this. Basically, what we're going to do is kind of say, like, we're giving a shout out here. Here's whom we want to join our set. So the set of all X is usually who we describe or what we describe as a member. Again, I don't know why X. It could be N, it could be R, whatever, but we generally write the set. We want the set of all X. So imagine that you're going for a job interview or an audition for a play or auditioning or trying out for a sport. It's basically saying, hey, here's who I want to come to this. So calling all actors, calling all football players, whatever. Here's what I want you to do. I want all X, and again, X could be football players, actors, waitresses, different things like that. And then we either draw a line here like this, or sometimes we'll see it written like this. And that means such that. All right, calling all X such that, right? Calling all X such that. And again, such that means you have this property coming up that I'm getting ready to describe. Calling all football players such that your height is over 6'2" and you've made more than 10 tackles during the year. Or calling all actors such that you have had a leading part and you know how to sing opera. All right, so I'm just getting ready to tell you what the qualifications are to be in this set. So this is who we want in the set, and these are the qualifications coming up. Now, this is the part that people get a little bit weirded out by because we start to see some more new notation. So before we do that, let me give you some examples of new notation. One is this funny looking E. This means is an element of, or maybe instead of element, you want to call it is a member of. All right, so is part of some group. The other thing you need to know are some of our symbols for sets. So we talked about this before. This means the set of natural numbers. And again, from our conversation before, this is 1, 2, 3, 4, 5, and so forth. For what we're going to talk about, actually, here's another one. This is the integers. Right, and again, that is this set that we just wrote up here, all positive and negative whole numbers. And then for our sheet, we're going to do a funny E means even numbers. And a funny O is going to be odd numbers. Okay, so this, I guess, would be pretty important. That's going to show up all the time. Is an element of, or is a member of, or is part of such and such group. All right, N for the natural numbers. Again, it's that funny fat N. Natural numbers are 1, 2, 3, 4, 5, and so forth. Integers, that would be all positive and negative whole numbers. E is the even numbers. Odd is odd numbers. Okay, so let's say we wanted to talk about this set right here. All right, I just wanted to get 2, 4, 6, 8, and 10. All right, so the first thing I would say is that these are even numbers. All right, so I would want to say that X has to be a member of the even numbers. All right, but if I just stopped there, I would get things like 12 and 14 and 16 and 18. So I also want to say that X has to be less than or equal to 10. All right. So I want it to be even and I want it to be 10. So again, calling all X such that, here are the properties, X has to be even and X has to be less than or equal to 10. All right, and again, I'm going to go back here. I forgot to write that these are the even and odd natural numbers. Because you might be thinking, why didn't you include 0? 0 is an even number, but 0 is not part of the natural numbers. All right, so the set of all X, the set of all things, the set of all numbers, such that, and here are the properties. X has to be even and X has to be less than or equal to 10. Okay, let's do another one. Let's say I want all integers that are greater than 5. So if I were writing it my old notation, I would say integers that are greater than 5. That would be 6, 7, 8, 9, 10, 11, 12. Actually, how about I do, well, let's just do that one. We can do more. So I'm going to start because I've already got that written. So I want this to be an infinite set, but I want to start at 6. All right, so all integers greater than 5. That's what we're trying to get to happen here. All right, so I'm going to start out the same way, calling all X's such that, all right, if you don't follow this description, just keep walking. I don't want you. All right, so first of all, I want X to be an integer, and I want X to be strictly greater than 5. I don't want to include 5. I want to start at 6. All right, so that's how I would write it. Calling all X, calling all numbers such that you are an integer. So if you're a rational number, if you're a natural number, don't bother to participate, all right? But you have to be greater than 5, all right? So if you're 4 or 3 or 2 or -7, don't bother coming, all right? You have to be an integer and you have to be greater than 5. Okay, let's do one more, and I want you to pause and think about this and see if you can write it out. Let's say I want this set. Okay, I want this set of numbers that are between -10, -9, -8, -7, -6, -5, -4, -3. So pause for just a second and see what you come up with. Now, it's not necessarily one way that you can write this. You might think of a different way than what I wrote. And if you did, please send me an email and let me know, and I'll let you know if you're correct or not. Okay, but just pause and see if you can write out what that would be. Okay, here's how I would do it. I would say the set of all X, here's what I'm looking for, all numbers X, such that, and again, you can use that or you could use the 2 dots, either way. And I want those, so the first thing I want it to be an integer. All right, and again, Z is that symbol for integers. And I also want it to be between -10 and -3, including -10 and -3. So I'm going to write it like this. All right. This says that x has to be less than or equal to negative 3. All right. Again, without that sign right there, if it were just x is less than negative 3, we couldn't include negative 3. This allows us to include negative 3. This side says that x has to be greater than negative 10 or equal to negative 10. Again, that little line underneath allows us to include negative 10. Without it, we couldn't include negative 10. All right, so this is just telling us that x has to be literally between negative 10 and negative 3, and we can include the endpoints. All right, so you might have written this in two separate parts. You might have said that x has to be an integer, and x has to be greater than or equal to negative 10, and x has to be less than or equal to negative 3. You could have broken it apart into two things like that. All right. Now, it's important that you have x has to be an integer, because without that, if you just said that it had to be between negative 10 and negative 3, you could have thought of things like negative 5 3/4 or negative 7.5. So this part right here is important so that we're not talking about negative fractional values that are between negative 10 and negative 3. All right. So you really need all of this in here, either written this way where it's combined into a double inequality into one single statement there, or broken apart into two separate ones. But again, that x is an integer has to be included. Okay, let's practice some on this sheet that you should have. All right, so in the first part here, we are going to do exactly what we were just doing, where we are writing it in set builder notation. All right, so I've given you a description of the set here. I want the set of odd numbers that are between 10 and 100. All right, so if we were just to write that out in our old way, that would be 11, 13, 15, 17, 19, and so forth, up to 99. This one's a bad one to start with. This one's a tricky one. But let's do that one. And then the ones that you get to do are the much easier ones. All right, so we'll do the hard one together, and you'll get to do the easy ones by yourself. Okay, so again, I start out in set builder notation. It always starts out with this, calling all x such that. All right, so first of all, if it's between 10 and 100, we're trying to decide what set to put it in. You could say integers. You could also say natural numbers. It doesn't specify. I definitely want to say either natural numbers or integers or whole numbers, because I don't want there to be negative numbers included in here. Or I don't want there to be fractions in here. So I'm just going to say the x has to be a natural number. You could say whole numbers, but we don't have a symbol for that, so it's nice to just be able to write that instead of have to write the whole word out. All right, so I'm looking for x to be a natural number, and x has to be between 10 and 100. I could either write that underneath or not. I don't want to include 10 and 100, but in putting that allows me to. But all the numbers we want are odd, so even if I said you could include 10 and 100, they wouldn't be included because they're not odd. All right, so now this is going to give me 10, 11, 12, 13, all the way up to 100. I don't want all those. I don't want things that are outside of that, which is why I'm putting that in, but I don't want all of the things that are included in there. So now I have to say that x is odd. So there are two different ways that I could do that. I could just come right out and say x is also in the set of all odd numbers. Actually, that would probably be easier if I just did that right from the beginning. X is odd and x is between 10 and 100. That's probably the fastest way to do it. Right? X has to be odd and it has to be between 10 and 100. We could even go a little bit further and say x has to be between 11 and 99. But then we must write that line underneath it. Okay. I was going to give you a much fancier way to do that, but that would be way too hard. So let's just say x is an odd number and it has to be between 11 and 99 inclusive, or we could say between 10 and 100, but not including 10 and 100. Okay. So then using that same idea, you can go ahead and do that. This is going to be even numbers. So again, remember that you can use E, this E, to stand for even numbers, the set of integers less than 0, and the set of natural numbers greater than 100. Okay, so I feel confident that, that with what we've said so far, you can do these three on your own. Okay, but now let's go down and look at this, because this is a whole different idea right here. They're giving us a description in set builder notation, and they want us to write what is in here. So it says list the smallest three values. They could be infinite like there are in some of these cases, or really large. So we're just going to write what we can. All right. So this says calling all x. Here's who I want to participate. I want you to participate if you're a natural number and you're greater than 5. Right? You have to be a natural number and you have to be greater than 5. So think about who would be in that set. Right? So could 5 be in that set? The answer to that is no. Again, if we had put that bar under that, that would say greater than or equal to, and then we would say yes, 5 could be in it. But without that symbol, then you have to be greater than 5 and a natural number. So I can't say 5.5, even though that's greater than 5, it's not a natural number. So the first number I could put in here is 6, then 7, then 8, and then it's just going to go on forever, right? All natural numbers that are greater than 5. So we've listed the smallest 3, but it goes on forever. Okay, the next set. Calling all x such that x is a member of the even natural numbers, so 2, 4, 6, 8, 10, 12, 14, and so forth. And it has to be between 10 and 30, not including 10 and 30. Again, this would include 10, this would include 30, but we don't have that. We don't want to include them. All right, so we're trying to think who is in this set, who qualifies for this role. All right, so I couldn't say 2, that's not between 10 and 30, or 4, or 6, or 8, or 10 even, because 10 is not allowed in here because of the strictly less than symbol. So the first guy that we can have in here is 12, then 14, then 16, and we would keep going until we got to the highest end of this. We would go 18, 20, 22, 24, 26, 28, 30. Oh, nope, 28 is the highest member of this set because we can't include 30. All right, so that would be the set. There's not that many. I should have just written them out. It would be 16, 18, 20, 22, 24, 26, 28. But it says just the smallest 3, so those are the only 3 that you would really need to include. Okay. This one says x has to be a natural number and it has to be strictly less than 20. Right? This is saying x is greater than 20. Oh, sorry, that was the wrong way. Glad I said that. This really is the same thing as x is greater than 20. It's just written in the opposite direction. Okay, so then, again, we're writing this out. So give me somebody that is a natural number that's greater than 20. All right, so hopefully you said 21 would be the first thing. Again, it didn't say even or odd, so we're just going to go with the next thing, then 22, then 23, and so forth. This is never going to end. It's just saying that x has to be greater than 20. Okay, you should be able to do 8, 9, and 10 on your own.